Alright, vector homework, question number 1. Alright, question number 1 says the coordinates of the points P, R, S, and T are. So, question 1, P is the point 2, 2, R is the point 5, 4, S is the point 3, 1, and T is the point 0, -1. Alright, so if you're given coordinates, one option that's available to you is to maybe do a sketch of what your diagram could possibly look like. So let's do a basic sketch. Alright, we don't have a lot of space, so let's try as much as we can. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and down here we have -1. The first point is P, which is the point 2, 2. That's P. 5, 4 is R. 3, 1, +3, +1. 3, 1 is S, and y-axis, which is the line x is equal to 0. 0 -1, which is here, is T. Alright, so those are my points. If I wanted to, I could maybe let's connect them. Alright, I could connect them. And also I could remove these dotted lines. Alright, so all I did was I did a sketch of the information that was given to me. Alright. Now, the next thing we're asked to do is to, the first thing we're asked to do is to write in the form x, y, the position vectors of P, R, S, and T. Alright, your position vector. Now, first of all, a position vector is a vector that is tied to the origin. Alright, so if I draw a line from what? Let's say the origin here, and the origin here would be what? O. Alright, so that would be the position vector, OP. Now, if I want to represent OP as a column vector, so this is the vector OP as a column vector. The top value representing the horizontal value, and the bottom value representing the vertical value. So in moving from O to P, I'd have to go what? 2 units right and 2 units up. That would make OP the vector 2, 2. The top value represents horizontal movement, and the bottom value represents vertical movement. Alright? Now, another thing about position vector is that the vector and the coordinates have the same value. So the coordinate of the point P is what? 2, 2, and the position vector OP is also 2, 2. So the position vector OR would be 5, 4. The position vector OS would be 3, 1. And the position vector OT is 0, -1. So this is a given fact, alright, that a position vector and the coordinates has the same value. Alright, the next thing is this. We need to B, determine in the form xy the vector PR. Now in vectors, so this was A, now we're at B, and we want to determine the vector PR. Now, most times when you're asked to determine a vector, you're going to use the triangle law of vector. Now with the triangle law of vector, you're going to start with P, end with R and the next letter goes in the middle. So the vector PR would be the vector PO plus the vector OR. Alright, now these vectors are up here. Alright, so this is the triangle law of vectors. The vector PR is the vector what? PO plus what? The vector OR. And these vectors are up here. Now, if OP is the vector 2, 2, PO would be the vector minus 2, 2. Alright? And the minus is just indicating that you're going in the opposite direction. Alright? So, PO would be going that way. And, sorry, OP would be going that way. And PO would be going in the opposite direction. So, if going from O to P is 2, 2, going from P to O is going to be what? Minus 2, minus 2. Alright, so it's you're going in the opposite direction. Now OR is the vector 5, 4. So if you add these, you're going to get minus 2 plus 5, minus 2 plus 4. Alright, so PR is the vector, what's that, 3, 2. So PR with this, which is this vector, would be the vector 3, 2. Alright. Now the next thing we need to do is we need to find what? RS. Similar thing using the triangle law of vector. So this is B II. Using the triangle law of vectors, we're gonna get what? RS. Vector RS is equal to the vector RO plus the vector OS. And this is using the triangle law of vector. So in vectors, most time when you're asked to find a vector, you're going to use the triangle law of vectors. To determine the vector RS, I must start at R, end at O, and the next letter goes in the middle. Alright, now since OR is 5, 4, RO would be minus 5, 4 plus OS, which would be 3, 1. So this would be minus 5 plus 3 minus 4 plus 1. So this would be minus 2 minus 3. Alright, and if you want, you could just say minus 2, 3. And this is the vector RS. So this is the vector RS. This is the vector RS. Alright, so as if you're going in that direction from R to S. What else do we need? We're asked to find. We're asked to find the vector ST. We're asked to find the vector ST. So that's from S going to T. Now, ST, if I want, I could say the vector ST is the vector SO plus OT. This is using what? Triangle law of vectors. OP, OR, OS, OT are called position vectors. And all these other vectors that we're finding, PR, RS, ST, those vectors are called displacement vectors. Alright, so SO would be minus 3, 1 plus OS, which is what? 0 minus 1. Sorry, OT, which is 0 minus 1. So what we have here is we have minus 3 plus 0 minus 1 minus 1. Because a negative times a negative gives you a, a positive times a negative gives you a negative. So what we have here is we have minus 3 minus 2. If the signs are the same, we add and keep the sign. Alright. So what we have here, this is what? Minus 3, 2. Alright. So that's going from S. That vector here is what? Is the vector minus 3, 2. Alright, the next thing we need to find is what show by a vector method that the figure PRST is a parallelogram and that the parallelogram is a rhombus. Alright, we found this one here, and this one is what, minus 2, 3, that's RS. The only one that we, the only vector we have not found is what, PT, or we could say TP or PT. Let's go for PT. PT would be the vector, would be what? PO plus OT. Alright, and again, that is using what? Triangle law of vectors. Alright, we've already answered all the questions. Now we're at in B of the question, now we're at C of the question. And the first thing we need to do is show that the thing is a what? Is a parallelogram, and 2, that the parallelogram is a rhombus. Alright, so this is C. Alright, and I'm not going to get CI yet. I'm going to do that in a second. Alright, so we have what? C, PT. So let's go for PT. We have PO, which is what? Minus 2 plus OT, which is 0 minus 1. So where is that coming from? Remember, if OP is what? 2, 2, PO would be minus 2, 2, meaning that you're going in the opposite direction. So this is minus 2 plus 0. This is minus 2 minus 1. Alright, so this is what? Minus 2 minus 3. If the signs are the what? Same, we add and keep the sign. So if we want, we could say that this is minus 2, 3. Alright. Now, CI says that we must what? Show. CI is saying that we must what? Show that the figure is a parallelogram. Now, what is a parallelogram? A parallelogram is a quadrilateral in which opposite sides are equal and parallel. To show that a quadrilateral is a parallelogram, we need to show that at least one pair of opposite sides are equal and parallel. Alright, so let's look at PT and what? RS. We can see that PT and RS are what? Are opposite sides. Now, if you look carefully, where is PT? PT is over there, and RS is here. You can see that the two are what? Oh, RS is here and PT is there. You can see that these two are what? Are equal vectors. Now, if two vectors, so we can see that what? RS is equal to the vector PT. Alright, and we already established that what? RS and PT are opposite sides of this what? Quadrilateral. Now, if these two vectors are equal, it means that they have the what? Same magnitude, and they have the same what? Direction. If they have the same magnitude, it means that the length of what? RS is equal to the length of what? PT. These two have the what? Same length. And RS is what? Parallel to what? PT. The line RS, the length of the line RS is equal to the length of the line what? PT. And that RS is what? Parallel to the line what? PT. So if these two, if opposite sides are what? Equal in length, these two are equal in length. Why are they equal in length? Because they are what? These are what? These two vectors are equal, meaning that they have the same magnitude and they have the same what? Direction. If they have the same magnitude, the lengths of the two sides are equal. If they have the same direction, the two lines are parallel. And if the opposite sides are equal and parallel, it means that therefore PRST is a parallelogram. What is a parallelogram? A parallelogram is a quadrilateral in which opposite sides are equal and parallel. To show that a quadrilateral is a parallelogram, we just need to show that at least one pair of opposite sides are equal and parallel. We just showed that the vector RS and the vector PT are equal vectors. If they are equal vectors, it means therefore that what? That the two vectors are what? The two vectors are what? Are the same magnitude and the same direction. Same magnitude meaning that the length of the two sides are the same. The same direction means that they are parallel. Therefore, if I connect the sides, PRST is a parallelogram. Now we need to show that it's a rhombus. To show that it's a rhombus, we need to show that all four sides are equal. Now, so that's not difficult actually. The sides are what? The magnitude of vector PT would be equal to the square root of PT is here, minus 2 square, plus what? Minus 3 square, which is equal to the square root of 4 plus 9 of 13. Then we have PR. The magnitude of vector PR would be, PR is 3, 2. So it's a square root of what? 3 square plus 2 square, which is the square root of what? 13. So we have done these two sides. Now we need to look at, we looked at what? We looked at PT and we looked at PR. Now let's go for RS. The magnitude of RS is equal to the square root of RS minus 2 square plus minus 3 square, which is still the square root of what? 13. Because this is 4, this is 9, 4 plus 9 is 13. And lastly, we have what? RS, we did RS, ST, where's ST? ST is here. So the magnitude of what? ST is equal to the square root of what? Minus 3 square plus minus 2 square, which is also equal to the square root of what? 13. So the shape is both a what? A parallelogram, and all four sides are what? Equal. A parallelogram in which all four sides are equal is a rhombus. So if I want in continuation of CII, therefore PRST is a rhombus. Alright, what is a rhombus? A rhombus is a parallelogram in which all four sides are equal. Alright, we have no more space on the board, but let us see what D is saying. And D is the last part of the question. D says, N is a point on line segment TR. N is a point on line segment TR. So somewhere on line segment TR, somewhere on line segment TR is the point N, such that the ratio of Tn to NR is what? 1 to 4. So the idea here is that you're dividing TR, the ratio of what? Tn to NR is 1 to 4. So that is the equivalent of saying you're dividing what TR into 5 equal parts. TN is what? 1 part, and NR is the next what? 4 parts. So imagine that we're dividing this into 5. 1, 2, 3, 4. Alright, so not so great there. Let's go again. 1, 2, 3, 4. So here's where I would put my N. So TN is 1 part and NR is the next one, 4 parts. 1, 2, 3, 4. Alright, so it would look something like that. Then now I'm asked to what? Determine the position vector of N. Determine the position vector of N. Alright, so to work that I need a little space. Alright, I didn't want to erase anything, but I don't have a choice. Alright, so use my hand. Alright, so Tn. Well, first of all, let's find Tn as a position vector. To find Tn, let us use, we need the position vector of N. To get the position vector of N, I need to, position vector of N, remember a position vector is a vector that's tied into the origin. So let me just say that again. We're asked to determine the position vector of what? Of N. Now a position vector is a vector that is tied to the origin. I'm guessing that I could say that ON I need the position vector of N. I have OT. I want ON. ON will be equal to OT plus TN. Good. Using what? I need ON. ON would be equal to OT plus TN. So we need to find TN. Now TN is equal to 1/5 of TR. I can't find TN, but I can find TR. TR would be equal to TR would be equal to TO plus what? OR. TO is minus 0, minus 1, and OR is 5, 4. So this becomes 0 plus 5 and 1 plus 4. So this becomes 5, 5. That's TR. TN, which is what? 1/5 of what? TR, which is equal to 1 over 5, 5, 5, which is 5 over 5, 5 over 5. So this is 1, 1. Alright, so why did I say 1/5? Why did I say that TN is 1/5 of TR? You can actually see for yourself. Remember, we divided what? TR into what? 5 equal parts. And TN is 1 out of the 5 parts. So TN is 1/5 of whatever TR is. Alright, so TN is what? 1, 1. So it means therefore that ON, which is OT plus what? TN, is actually equal to minus 0 minus 1 plus 1, 1. So this becomes 0 plus 1, 1 plus 1. So it means that ON is the position vector 1, 2. Alright, so what were we asked to do? we're asked to find what? Determine the position vector of n, and the position vector of n, which is ON, is the vector 1, 2. Alright, so this is the end of the question. The only thing I would add is that this is a long time question, and that the question you will do in your exam will not be this detailed. You will not be asked to do so many things. But it's a very good question, one in which I suggest that you should try on your own.